Hello, algebra students, and thanks for tuning in to our video, in our first video actually, in our new unit titled Solving Systems of Equations. So these are our notes on solving a system of equations by graphing. This will solely devote itself to graphing. But before we get into it, I thought it would be good to write down or read with me the definition of a system of equations. So basically, this entire unit deals with this notion of a system. We've been dealing with equations for quite some time, but now I'm adding this word system to the front. So what does that mean? Well, let's take a look. It says a system of equations is a collection of two or more equations with the same set of unknowns. So I really want to highlight two or more. So we're not going to be dealing with just one equation anymore. We're going to do a 2-for-1 special. In solving a system of equations, we try to find values for each of the unknowns that will satisfy every equation in the system. So basically, what we're going to do is we're going to take two equations that have x and y as part of each of them, and we're going to try to find the x and the y that makes both equations true. So a system of equations, two or more equations. Okay, so let's read our directions here. It says for each example below, solve the system of equations by graphing. In other words, graph each line in the system of equations and find the point where the two lines intersect. This point will satisfy both equations in the system. So if you're a good grapher, this is a really simple concept. So let's take a look at example 1. Example 1 says, solve the system by graphing, and it gives us two equations. So this will be equation number 1, and this will be equation number 2 in the system. So let's start by graphing equation number 1. So you can see it's in slope-intercept form. We've got a y-intercept of positive 3 with a slope of negative 2. So to graph that, we know from the last unit, we're going to come up on the y-axis 3 units, that's our b. And from there, we're going to come down 2 because it's negative and right 1. Down 2 and right 1. And when I'm doing systems by graphing, I like to keep going as far as I can in both directions. I want a really accurate line because I need to find where two lines are intersecting. So if you can see, I ran the whole gamut of the XY plane there, and I'm going to use a ruler to be super accurate and draw my line. Okay. Now the second line in the system has a y-intercept of negative 3 with a slope of positive 1. So we're going to come down the y-axis to negative 3. 1, 2, 3. And from there, my slope is up 1, right 1, up 1, right 1, up 1, right 1. And I'm going to keep on doing that as far as I can go till I run out of room. And I can also do the opposite. I can come down 1, left 1 to get some points in the other direction. And I'm going to draw that line. And hopefully they intersect somewhere, which I think by now you can see that they do. So the solution to this system of equations is the point. It's the value of x and y that belongs to both lines. So this point right here, let me kind of put a red dot over top of it. This guy right there looks to be the x is 2 and the y is negative 1. So that's the point of intersection. This is the solution. And let me show you how to check your work. So what you do is you take the first equation, okay, number 1. So this is number 1. And where the y is, you're going to fill in a negative 1. And where the x is, you're going to fill in a 2. And we're going to see if it's a true statement. So here we go. It would say negative 1 equals negative 2 times 2 plus 3. If I do the math, negative 1 equals negative 4 plus 3. And negative 1 equals, well, that's negative 1. So that's a true statement. So this guy right here, 2, negative 1, is a solution here algebraically to the first equation. Now, if I take the second equation, where the y is, again, I'm going to substitute negative 1 equals x, which is 2 minus 3. So negative 1 equals negative 1, also true. So algebraically, this is showing that this point satisfies, going back to that word from up top, satisfies every equation. And by graphing, we see that that indeed is where the two lines intersect. So isn't that pretty easy? Okay, let's go to the second example. Example 2. Solve the system by graphing. Okay, so we've got y equals x minus 4 and y equals 3x minus 6. So let's graph our first line. We'll call this line number 1 and this line number 2. So our first line has a y-intercept of negative 4 with a slope of 1. So let's go ahead and graph that line. We'll come down 4 on the y as our b value, and then up 1, right 1. And we'll just continue doing that as long as we can. And the other direction. And there we'll have a nice line. Get your ruler and connect those dots to form your line. Okay, and then line number 2 has a y-intercept of negative 6 and a slope of 3. So we're going to come down 6, and then we're going to rise up 3 and right 1, up 3 and right 1, and keep that going. Okay, and I can't go in the other direction. I don't have enough room, so I'll just connect those dots. And sure enough, the two lines intersect, and they intersect, it looks like, right here. So the solution is the point of intersection, so that looks to be like 1, negative 3. Now, you can certainly run a check. I'm not going to do the check on this video just for time's sake, but you can run a check algebraically just like we did on the front side. Okay, example 3, solve the system by graphing. What's interesting about example 3 is look at these two equations. I want you to think to yourself quietly what form these are in. And hopefully you're thinking standard form. And the trouble with standard form is we can't see the slope or the y-intercept. So I'm going to transform both equation number 1 and equation number 2 into slope-intercept form so that I can graph them more easily. So let me bring number 1 over here to the right. I'm going to recopy it. 4x minus y equals 3. And I'm going to start by taking my x term over to the other side. I want to get y equals. So I'm going to subtract 4x from both sides, which is going to cancel those out. This will leave me with negative y equals negative 4x plus 3. And now I don't want that negative in front of my y. So if I think of that as being a negative 1, I'm going to go through and divide each term by negative 1 to get rid of it. That will cancel those out and give me y equals positive 4x minus 3. So this is my new and improved equation number 1. Now, equation number 2. Let me switch colors here. Equation number 2 is negative 3x plus 2y equals negative 4. Same idea, it's in standard. I'm going to move my x term over to the right side by adding 3x to both sides. Cancel. And now I have 2y equals 3x minus 4. I'm going to divide everything by 2 to give me a final answer of y equals 3 over 2x minus 4 divided by 2 is 2. So this is my new and improved equation 2. Now we're ready to graph. So let's go back to equation number 1. Equation number 1 has a y-intercept of -3 and a slope of 4. So let's get that rolling. Y-intercept -3 coming down 3. And then I'm going to rise 4. 1, 2, 3, 4, and run 1. 1, 2, 3, 4, run 1. I'm out of room there. Let's see if I can go the other way. 1, 2, 3, 4, and left 1. Yep, got one more point on there. So my line, right there. Okay, now line number 2. Y-intercept, -2, slope, 3/2. So I'm going to come down 2, 1, 2, and then I'm going to rise 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Can go the other direction, 1, 2, 3, 1, 2. And that looks about right. So I'm going to hook my dots up here, draw my line. Okay, now this is pretty interesting. To be honest with you, if I'm being completely honest, when I grabbed this example, I did not realize this was going to happen. Do you notice something here? The point where they intersect, right about here, doesn't it look like it's a decimal? Like, to me, it's not quite on a corner. And I just want to double check I did everything right. I came down 3, up 4 and over 1, and then I came down 2 and up 3 and over 2. Yeah, I'm pretty sure I did everything right. Let me check my math again up here. Oh, sugar. 3 divided by, yep, -1. Okay, well, it looks like it's time to bring the TI-84 on the scene. Okay, I'm going to show you something pretty cool here. So when you're doing graphing method and you get an intersection point that is not on a perfect corner, you can use your TI-84 to get the answer. It's pretty cool. So what I want you to do is turn your calculator on, and I want you to press y equals. And I want you to hit clear. You see I have some stuff in there. Clear out any old junk. And into y1, we're going to type our first equation. Y equals 4x minus 3. So let's do that. So y equals 4x minus 3. And in y2, 3/2 x minus 2. 3/2 x minus 2. Okay, now we're going to check our window. Can you guys see that? There's a bit of a glare on there. We're going to check our window. I want you to press window, and mine's a mess. I want your x min set at -10. I want your x max set at +10. And I want your x scale set at 1. I want your y min at -10, your y max at +10, and your y scale at 1. Once you have your window set, press down graph right here on your upper right corner, and hopefully we have the same two lines that we have. If you look at the graph here and you look at the graph here, they look the same. Now, the way to find the point of intersection on a TI-84 is pretty simple. You see this trace button right here beside graph. It says trace. Well, above that in blue, it says calc. And so we want to calculate a point of intersection. So we have to depress the second button, second, and trace, and you get this menu. I want you to come down to number 5. We want to see where these two lines intersect. So go ahead and hit enter. And now look at the bottom of your screen here. See how it says first curve and there's a question mark there? All you have to do is hit enter. Then it says second curve, question mark. What the little cursor did is it jumped to the other line. So just press enter. And then it says guess. And what they want you to do is use your arrow pad, your right or left arrows, to pull the cursor over top of where you think the intersection looks to be, which it put us right in that neighborhood. So you can kind of just leave it blinking there and hit enter. And as you can see, look at the answer. It's glaring here a little bit, but hopefully you can see it on your screen. The answer is x equals 0.4, y equals negative 1.4. So that's what I'm going to write down as my solution. X is 0.4 and y is negative 1.4. Now, I don't want you to use this like on your mastery today. I don't want you to use the calculator unless you need to. You could also use it to check yourself, but I definitely want you to practice your graphing by hand. So I don't want you to lean on this completely, but know that that's there to check your work or to get those answers that may be a little bit uglier or decimal. So in all honesty, I didn't know this was going to happen on this video, but I'm kind of glad it did because I was able to show you something cool on the TI-84. Okay, let's go to our last example. This is more of a word problem. It says, Thrifty Rentals rents a sander for a flat fee of $8 plus $3 per hour. So Thrifty Rental rents the sander for $8 plus $3 an hour. Premier Rentals rents the same sander. So Premier, let me do a different color highlighter, different store, for a flat fee of $5 plus $4 an hour. Letter A says, write a linear system of equations you can solve to find the length of rental time for which both stores charge the same amount. Okay, well this should be pretty easy. So what I'm going to do here is I'm going to head this up first with Thrifty Rentals. Let's write an equation for Thrifty Rentals. And let's let x equal, you know how I always say if there's time involved, you want to let x be your time because time depends on nothing. So x is going to be the number of hours you rent the sander. And then y will be the cost to rent the sander. Because the cost is going to depend on how many hours you've rented it. Okay, so then our next equation, we'll make it number 2, is going to be Premier Rentals. So let's write a different equation. Well, look at this. I didn't even... Oh, I'm having a day today. I didn't even write the equation. Let me go back. For Thrifty Rentals, the equation is going to be y equals, so my cost equals $3 per hour. That means multiplication. So $3 per hour plus the $8 rental fee. The flat fee is $8 and the per hour cost is $3. Okay, now I'm ready for Premier. For Premier, I'm going to let the x and the y be the same as above, but now my cost, y, is dependent upon the flat fee of $5 plus the $4 per hour. So $4 per hour multiplication plus the flat fee. The flat fee always becomes the b value. So we've got two different equations. So let's graph them. Let's start with the red line, Thrifty. So I'm going to start at positive 8, and then I'm going to go with my slope of up 3 over 1. And this represents for every hour, 1, 2, 3 over 1, for every hour I rent the sander, my cost is going up by $3 every hour. So there's that line. And my other line starts at positive 5, so a little bit lower up front. And then I'm going to go up 4, 1, 2, 3, 4, and over 1, up 2, 3, 4, over 1, up 2, 3, 4, over 1, and up 2, 3, 4, and over 1. So this line is going to look like this. And you can see that the two lines intersect right here at the point 3 and 17. So at 3 hours, no matter which store you go to, it's going to cost you $17. Okay, final question. Suppose your neighbor hires you to sand her wood deck. Which sander should you rent and why? I want you to pause the video and think about that, and then come back to the video when you're ready. So here's what I'm thinking. If you're back with me now, here's what I'm thinking. If I can sand the neighbor's deck in under 3 hours, then I should rent from, now let's look. So here's 3 hours. Let's look to the left of 3 hours. So if I can do it in 0 to 3 hours, do you see how the blue line is under the red line? So I would rent from the blue. If you go up here at 1 hour, see the blue line only costs me $9. The red line's going to cost me $11. So Premier is cheaper if I can do the job in under 3 hours. If the job will take me more than 3 hours, then I should rent from Thrifty. Because as you can see, if I'm doing like a 5-hour job here, if I come up 5 hours, the red line all of a sudden is under the blue. So then I should rent from Thrifty. So the meeting point is kind of where the divide happens and things start to shift. Now, if I can do the job in exactly 3 hours, well, they're the same cost, $17. So it doesn't matter who I rent from if I can do it in exactly 3 hours. Okay, thanks for watching and good luck on your mastery.